The greater the mass of the object, the greater the impact or dent on the space-time fabric. This isn't just in theory, here's the evidence. These Hubble telescope images show what is happening to light as it travels through space. As light passes a galaxy, its path bends. By examining how light bends as it travels, we can prove that mass is bending space-time. This experiment replicates this phenomenon in a lab. It's a mini-universe, and it shows how light travels across space-time. In flat space-time, a light beam follows a straight line. But there is evidence that light is bending as it travels through the universe. The path it follows must also be bending, and that path is space-time itself.
Billions of stars are bending the space-time, acting like a lens. So a lens curves light, and if you bend the space-time, the light will curve. So you get the image of the galaxy in the middle, but then you get these really distinctive rings around. And that's strong evidence, overwhelming evidence, that mass bends space-time.
This warping of space-time will help us to build our time machine. When gravity bends space-time, it has a very real effect on how time passes. Here on Earth we might not feel it, but time runs slower on the ground floor compared to at the top of a skyscraper.
The closer I am to the Earth, the more curved the space-time, the stronger the gravity, and the slower time ticks. Whereas here, space-time's a little bit less curved, gravity's weaker, and so time ticks faster. Now, it's a really tiny effect. If I was to stand at the top of this building for 100 years, then my watch would be 50 millionths of a second faster than somebody's watch down on the ground. So in a sense,